System software. System software began in the late 1940s and early 1950s when computers were first invented. At that time, computers had no easy way to manage hardware. Every instruction had to be written manually, directly for the machine. That was slow, complex, and error-prone. System software was created to solve this problem. Its main job was to act as a middle layer between the hardware and the user. Instead of controlling memory, processors, and storage by hand, the system software handled it automatically. Compared to having no software at all, this was a massive improvement. Early operating systems could manage tasks, allocate memory, and control input and output devices. Even simple scheduling made computers far more practical. Early systems worked at very low speeds, often measured in kilohertz rather than megahertz. Memory was tiny, sometimes just a few kilobytes, but even with these limits, system software made computers usable beyond laboratories. This type of software was best for engineers, scientists, and government organizations that needed reliable control over expensive machines. The limitation was flexibility. Early system software was hard to modify, supported only one task at a time, and required expert knowledge. Still, it laid the foundation for everything that came after. Application software. By the 1960s and 1970s, system software had stabilized. Computers could run programs reliably, but they still weren't very useful for everyday tasks. Most people couldn't write their own programs, and computers had no tools for specific jobs. Application software was created to solve this gap. Instead of controlling hardware, it focused on helping users do tasks like calculations, writing, or data processing. Compared to system software, application software was more user-focused. Programs like early word processors and spreadsheets allowed people to work without understanding how the computer worked internally. These applications ran on top of the operating system, using its services instead of replacing it. Storage was still limited, often measured in megabytes, so applications had to be small and efficient. This software was ideal for businesses, offices, and educational institutions that needed productivity tools rather than raw computing power. The drawback was specialization. Each application usually did only one job, and switching between programs was slow. Still, application software made computers practical for non-technical users. Utility software. As application software became common, a new problem appeared. Systems became harder to maintain. Files got corrupted, storage filled up, and performance slowly degraded. Utility software was created to solve these maintenance issues. It focused on keeping the system healthy rather than doing user tasks. Compared to application software, utilities worked behind the scenes. Disk cleanup tools, antivirus programs, and backup software helped protect data and improve reliability. Early utilities worked with very limited storage, sometimes managing disks smaller than 100 megabytes. Even basic cleanup could noticeably improve speed on slow systems. This software was especially useful for system administrators and office users who needed stable, long-running computers. The limitation was visibility. Many users didn't understand what utility software was doing, and early tools had very simple interfaces. Even so, utilities extended the life and reliability of systems built on earlier software types. Firmware. By the 1980s, computers were becoming more standardized. However, hardware still needed basic instructions before any operating system could load. Firmware was created to solve this startup problem. It is software stored directly on hardware chips, not on hard drives. Compared to utility software, firmware runs first and at a much lower level. It tells the computer how to start, recognize hardware, and load the operating system. Firmware is very small, often just a few megabytes, and stored in non-volatile memory, so it stays even when power is off. This type of software is ideal for manufacturers and hardware designers who need reliable startup behavior. The downside is flexibility. Firmware updates are risky, and mistakes can make hardware unusable. Still, firmware forms the bridge between raw hardware and system software. Middleware. In the 1990s, computers began connecting to networks and servers. Applications started communicating with each other, but doing this directly was complex and unreliable. Middleware was created to solve communication problems between different software systems. It sits between applications and system software, handling data exchange. Compared to firmware and utilities, middleware focuses on coordination rather than control. It allows programs written in different languages to work together. Network speeds during this era ranged from a few megabits per second to around 100 megabits, and middleware helped manage data flow efficiently. This software was ideal for enterprises, banks, and large organizations running multiple connected systems. The limitation was overhead. Middleware added complexity and sometimes slowed systems. Still, it enabled large-scale software systems that weren't possible before. Driver software. As hardware variety exploded, operating systems couldn't natively support every device. Printers, graphics cards, and sound cards all behaved differently. Driver software was created to translate hardware behavior into something the operating system could understand. Compared to middleware, drivers work much closer to hardware. They convert generic system commands into device-specific instructions. Drivers often control performance directly. For example, graphics drivers can affect frame rates, sometimes by 10 to 30% depending on quality. This software is essential for normal users, gamers, and professionals who rely on hardware performance. The drawback is compatibility. Outdated drivers can cause crashes or prevent hardware from working. Still, drivers allow system software to support endless hardware variations. Mobile software. Before 2007, software was mostly designed for desktops. Then smartphones changed how people interacted with computers. Mobile software was created to handle touch input, small screens, and limited battery power. Compared to traditional application software, mobile apps are lightweight and optimized. Many apps are under 100 megabytes, designed to run efficiently on battery-powered devices. This software is ideal for everyday users who want communication, navigation, and entertainment on the go. The limitation is power. Mobile software has restricted access to hardware and less multitasking capability than desktop systems. Still, it reshaped how software is designed and consumed. Web-based software. As internet speeds improved, installing software became less necessary. Many tasks moved into the browser. Web-based software was created to eliminate installation and make software accessible anywhere. Compared to mobile software, web apps rely heavily on internet connectivity. With broadband speeds reaching 50 to 100 megabits per second, performance became acceptable for daily tasks. This software is great for students, remote workers, and collaborative teams. The downside is dependency. Without internet access, functionality is limited. Still, web software simplified updates and cross-platform compatibility. Anyway, I also made some other cool videos too, so don't forget to watch them later, okay?